I'm Abdul Tofik, Assistant Professor, SNS College of Physiotherapy. Welcome to the lesson of force and equilibrium, which comes under the basic applied physics of mechanics and biomechanics. Today we'll understand the how force act on human body and how equilibrium supports the posture and stability. To empathize the topic, physiotherapy is everything behind with observation. We notice how patient struggles with balance and instability and how posture changes under the fatigue or pain. Understanding these real life challenges help us to retreat or not just to teach. To define, after observing, we define the core problems. Many patients lack stability because internal and external force are not balanced. So our goal is this in this lesson is to identify the concept of equilibrium that influence the therapeutic outcomes. So this is our goal. So coming to the ideate, in ideation phase, we connect biomechanics to practical correction strategies. We think about how force, torque, and equilibrium helps to improve posture and movement efficiency. So coming to prototype, here we translate theory into action. We develop rehabilitation models like traction setups, weight balance activities, stability and balance drill. These helps patients physically experience equilibrium principles. To test, in the testing stage, we apply these methods with patient and adjust based on outcomes. No single approach fits all. Clinical reasoning depends on feedback and performance. So let us move into the core theory. A force is a push or a pull. It is calculated as F is equal to ma, means mass and acceleration. Mass into acceleration. Force is equal to mass and acceleration. And the unit is Newton. Force can change the state of rest of motion. This is the foundation of movement therapy. So the characteristics, every force has four characteristics: magnitude, direction, point of application, line of action. In physiotherapy, these determine whether movement becomes efficient or strained. We ideal types of force. So we ideally with two major types of force: internal force and external force. So what is internal force? Muscle, ligaments, and joints reactions are internal force. And what is external force? Gravity weights around the reaction, friction, rehabilitation success depends on balancing these forces. So, what is the compression and distraction? Compression is a pushing force. Distraction is a pulling apart force. Clinical clinical examples are include spinal loading during standing versus clinical traction during therapy. So, force system: linear force, concurrent force, and parallel force. These are the three types of force. Linear force, force in the same line. Concurrent force, force meeting at one point. Parallel force, force acting in the same direction but not along the same line. The type of system determines the movement and balance outcome. So coming to the torque. Torque is the rotational effect of the force. It is calculated as torque is equal to force into distance. In exercise therapy, adjusting lever arms length can reduce joint stress and increase efficiency. Equilibrium occurs when the sum of all forces and torques equals zero. We see equilibrium clinically in static balance while standing, dynamic balance during walking. Types of equilibrium: stable equilibrium and unstable equilibrium, neutral equilibrium. Stable equilibrium returns the position of after distribution. Unstable equilibrium moves further away when distributed, stays in new position. We can compare them to book a pen and a ball. So clinical relevance. Understanding force allows to design the safe and effective rehabilitation program, whether it balances retraining, postural correction, or strengthening force management in essential patient's recovery. So, to review or summarize the topic, force imbalance affects posture and stability. We can improve equilibrium using balance training, muscle strengthening, and ergonomics alignment. So, what are the questions maybe I ask in this? Define force and equilibrium. Differentiate internal and external force. A patient cannot maintain standing. What force are acting? And the fourth question is suggest one method to improve equilibrium. These are the questions may ask in this topic or most important questions for this topic. So make it clearly. And thank you for your attention. See you in the next class.